in the previous lectures we have seen comparator segment. We will continue the same lecture, but let's take a short review of the previous lecture. In the lecture first, we have seen comparator and its applications. In the second lecture, we have seen different types of comparators and we were elaborating different comparators. The first was mechanical comparator. As you remember, the very first basic comparator was mechanical dial indicator, or it is also called as dial indicator. The small advancement in the dial indicator given us the very second comparator of mechanical segment, that was Johansson's microcator. Since it was having somewhat positive advantages and negative disadvantages, we have added up the next category, and the category was mechanical optical comparator, where the mechanical fluctuations were advanced onto the optical illusion system using projection and set of condensing lenses. Now we have gone through the disadvantage points as well, and we will be moving to the next reliable category. Now, why the word reliable is important? The duo mechanical and mechanical optical comparator has given us some sort of less reliability. We will move to the next category, that is electrical comparator category. And electrical comparators are well known for their reliability. You can see the diagram where it is in the most simplified format. Electrical supply will be given through electrical setup. Display screen will give us either analog reading or either digital reading on the screen, of course. The connection from the electric supply has been given to the plunger. Of course, plunger is the most integrated part of the comparator segment. The plunger is connected or is in the touch with the connecting head of the component. The component is in the cylindrical dimensions, so by the adjustment of which structure it is connected to the work table, you can clearly see. The height adjustable handle will give us a small relief as per the workpiece dimensions. If it is smaller, we can down up the plunger. If it is in bigger condition, we can up the height adjustment. Now, the point of working, how working occurs, let's see. The electrical supply will give electrical signal to plunger through this connection. Plunger will be moving in y plus y minus direction as per the signal, and vice versa. Any small dimensional variation. Now the dimensional variation may occur in two forms. The very first, top, that is the crest, and bottom, that is the downside. So plunger will record the movement. It will go plus minus, and very small, or you can call it as a minute change will be noted and will be sent back to electrical supply. Now electrical supply unit will record the minute change and it will display onto the segment of display section. So this is the working of electrical comparator in most simplified format. Next, since we have seen the comparator working, the comparator again have some advantages and disadvantages. We will try to cover one by one. Measuring units can be remote from indicating units, so we can manage the distance between actual measurement and display measurement. Variable sensitivity which can be adjusted as per requirement, of course. No moving parts, hence it can retain accuracy over a long period. That means no wear and tear, therefore no replacement of parts inside that. Higher magnification is possible as compared to mechanical comparator. Compact sizes of probes are available. So the component may be smaller in dimension or larger in dimension. You just have to change the touching probe and you will get the accurate reading. The disadvantages are the accuracy of working of this comparator is likely to be affected due to temperature. Since there is an electrical supply, so humidity and temperature difference may affect slightly. It is not a self-contained unit, it needs stabilized power supply for its operation. Since direct electrical operation is not possible into that, heating of coils can cause zero drifts and it may alter calibration. So after use, the calibration is required somewhere. It is more expensive than mechanical comparator, so that is the disadvantages. But if it is going to be used for a prolonged period, the cost is going to be minimized. Next, pneumatic comparator. As promised, this is the pneumatic comparator and we are going to see the working of it. Principle, let us first note down what is the basic principle behind working of that. It works on the principle of pressure difference generated by the airflow. So air will be the major parameter for the measurement. Air is supplied at constant pressure through orifice and air escapes in the form of jets through a restricted space which exerts a back pressure. The variation in the back pressure is then used to find dimensions of the component. We will directly go to the diagram instead of reading this theory. Now, as the diagram indicates or defines everything, what we will see one by one, working of pneumatic comparator. The compressor on the very left gives compressor supply of air on a constant time basis. The filter will remove any particulate matters through generated by compressor or in the air. The orifice is there. Now orifice is connected to the deep tube and water tank is connected to manometer will give a constant pressure of the air. The air will further pass through the gauging head and gauging head is pushed into the jaw. Now the pneumatic comparator can be used very widely for the intricate holes or to measure different diameters or any plus minus in the diameters. How? The air will be passing at a constant flow rate that is indicated on the manometer. If there is any up by the casting defect or by the forging defect or any down or any bubbles or any shrinkage or any gap or any crack, these all are defects which will give an extra passage of air to flow, and if extra air is flow, then the manometer will give us the reading over a large scale. So by counting where extra air has been passed or where less air has been received, we can judge where there is an actual defect. In this diagram, you can see the air jet is passing at a A1 point on a constant pressure, but A2 is having somewhat deflection, A3 is having some more deflection, so it will give number of reading. Likewise is the operation of pneumatic comparator. Next, so again moving to the advantage and disadvantage segment of pneumatic comparator. It is cheaper, simple to operate and low costed. It is free from mechanical hysteresis and no wear and tear may affect. The magnification can be obtained as high as 10,000x. Earlier we have seen magnification up to 1,000, 2,000, maximum to 3,000x, but here we can obtain at such high quantity. The gauging member is not in direct contact with the work. Indicating and measuring is done at two different places. Tapers and overheating can be easily detected. The method is self-cleaning due to continuous flow of air through the jets and the makes method ideal to be used on shop floor for online controls. Moving to the disadvantage segment, they are very sensitive to temperature and humidity changes because if humidity increases, airflow or compressor air will be affected. The accuracy may be influenced by the surface roughness of the component being checked. Different gauging heads are needed for different jobs. Auxiliary equipment such as air filter, pressure gauge and regulators are needed, so they have added up in the total machinery. Non-uniformity of scale is peculiar aspect of air gauging as variation of back pressure is on a linear scale over only a small range of the orifice size variation. So these are the advantages and disadvantages. But we have got one constant point that as the complexity of the comparator segment increases, the reliability also goes on increasing. But at the same time, the external factors like air pressure, temperature, humidity may affect smallly for the readings. So it's the system that mechanical comparator will give the constant reading but for a small number of time, and the wear and tear will be more. Mechanical optical comparator will give us the magnified readings. Sigma comparator will give us the accurate reading, but it depends on the external power factors such as electricity. Electrical comparators will give us more prominent reading, but it requires a constant source of electricity, and some hysteresis or continuous reading may give us the heating of the instruments. Pneumatic comparator is an accurate form, but air is the most affecting or getting affected part of the comparator. So every comparator has its plus and minus, but dependent on the component size, component shape, and material of the component, we can select one of the comparators as per our requirement. We will continue the lecture series in the next time. Thank you till then.